Welcome to an exploration of machine learning. Let's discover how computers can learn from data. Machine learning is a revolutionary approach that allows computers to learn without explicit programming. To understand machine learning, let's compare it with traditional programming. In traditional programming, we provide rules and data to get answers. But in machine learning, we provide data and answers, and the computer learns the rules. One of the most common applications is pattern recognition. Let's see how a machine learning model can learn to distinguish between different shapes. The computer learns by analyzing many examples, finding patterns in the data. As the model processes more data, its accuracy improves over time. The learning curve shows how the model's accuracy increases as it sees more training examples, eventually reaching a high level of performance. In supervised learning, the computer learns from labeled examples. Each training example is labeled with its correct category, like these colored blocks labeled red and blue. When given a new block, the model can predict its category based on what it learned from the training data. Unsupervised learning works differently. The computer finds patterns in unlabeled data. The algorithm discovers natural groupings in the data, like these two distinct clusters. Reinforcement learning involves an agent learning through trial and error. The agent starts at one point and must find its way to the goal, learning from its successes and failures. Through many attempts, the agent learns to find more efficient paths to reach its goal. Let's explore how a neural network processes information through its layers. When data enters the network, it flows through connections between neurons, with each connection having a specific weight or strength. The network learns by adjusting the strength of connections based on the error in its predictions. As the network trains, the error decreases from 0.5 through weight adjustments. As the network trains, the error decreases from 0.3 through weight adjustments. As the network trains, the error decreases from 0.1 through weight adjustments. After training, the network can make accurate predictions by processing new data through its optimized connections. This process of forward propagation and weight adjustment continues until the network achieves satisfactory performance. To train a machine learning model effectively, we split our data into three parts. The training data, which makes up about 60% of our dataset, is used to teach the model. Validation data, about 20%, helps us check if the model is learning properly or just memorizing. The remaining 20% is our testing data, which we use only at the end to evaluate the model's final performance. During training, the model processes the training data multiple times, adjusting its internal parameters to improve accuracy. As training progresses, we track both training and validation accuracy. When validation accuracy stops improving or starts decreasing, we know it's time to stop training to prevent overfitting. Once training is complete, we can use our model to make predictions on new handwritten numbers. The model assigns a confidence score to each prediction, indicating how sure it is about its answer. Let's explore how machine learning helps filter spam emails from your inbox. The system analyzes various features of each email and assigns confidence scores to determine if it's spam or legitimate. Movie recommendation systems analyze viewing patterns and ratings from similar users. By finding users with similar tastes, the system can suggest new content you might enjoy. Virtual assistants use multiple machine learning models to understand and respond to your queries. Your request goes through several processing steps: speech recognition, natural language processing, context analysis, and response generation. Finally, the system generates an appropriate response based on the processed information. Self-driving cars use machine learning to understand their environment in real time. The system continuously detects and classifies objects like other vehicles, pedestrians, and road signs. Based on these detections, the car plans a safe path and makes driving decisions.